All right, back again. Okay, so one of the things I was saying was I was going to show you guys kind of, now again, this is a style thing. This isn't necessarily one of them is, there could be that one of them is better for the purposes of efficiency, like in execution, but not always. Okay, so let's take a look at the where salary is greater than sum of one of these. Okay, so let's first show again. Let's do this. Let's do it there. Okay, and I'm going to comment out all of these. Okay. So that when we see what happens here, we're going to see all of the salaries that are from B003. Okay, so again, 12, 18, 24. Okay, so now if we say I want to get all salaries where their salary is greater than some salary from here. Okay. Okay. So all salary information, staff number, and their information where their salary is greater than some salary from that other. But really, like I said, what we're saying is their salary has to be greater than what? The minimum, right? The minimum salary, right? So if I said, click that out. Min salary, all right, from here. We'll see that we'll get the same results as we did before, right? Okay. And the reason why is because we're saying where the salary is greater than the minimum, which means that it's greater than some value from this results set, right? Okay. Now, the other one they said was what was greater than all. There. Greater than all salaries from here, which should give us only one result, right? Yep, one result. So if we said this the way that I would have written this, instead of min here, it's max, right? Where it's greater than the maximum salary, because if it's greater than the maximum, it must be greater than all of them, right? Okay. All right. Okay. And again, which one of these is better? It depends, right? We don't know. We don't know which one of these is going to work better. Now, I could sit here and look at, okay, this one took 0.001 seconds. If I did it as the all and took out max at, this one took 0.0004 seconds, so it's a little bit faster, right? But is that always going to be the case? We don't know. And in fact, actually, little side note, that is one of the things that the job of a database administrator will do. So anybody interested in pursuing a role as a database administrator, one of the things that they do is they fine-tune the database to make sure that the queries are not slowing things down or running as efficient, or they are running as efficiently as possible. Okay, so what they would do is they would run those queries over and over again and see which version of that caused more, was slower on average, not just in one situation, but which one of them was slower on average and which one was faster. And they would basically suggest that we use the fastest version. Okay, all right. Now, we talked about subqueries. Talked about how we could use the results from one subquery to be as the input to the where clause or to the select or from of an outer query, right? But what if we want to get results from more than one table, right? What if we wanted, in addition to all the staff people who work at a particular branch, at a particular address, we want to know what's the city for that branch, or what's this for that branch, something else from the branch table. We can't do that with subqueries, but we can do that with using multiple tables joined together. Okay, so in the from clause, we can put multiple tables. There's not just one way to do that. We'll show some examples here in just a moment. Okay, but we can also use an alias for a table in the from clause so that it becomes easier to type those things later. Okay, qualify column names using theirs as an alias. Okay, so this example. Okay, we want to list the names of all clients who have viewed a property along with any comment that they supply. Okay, so if they viewed a property and gave a comment, which term is more portable? William asks. Some or men. I'm thinking men, since it's a common aggregate function. In fact, it wasn't until in my work in the industry, we only used men. The version that I showed you, the way I would write these queries, the reason I wrote them that way is because I only ever used men. I didn't even know that some existed until I started teaching this class a number of years ago. So leads me to think men is better, but yeah, sometimes we just do things the way that we do them. All right, so we can say I want to get the clients, and if they viewed have viewed a property, and if they gave a comment. Okay, so I want the client, their first name, their last name, their property number that they viewed, and what comment did they leave. Right. Now, client number, first name, last name, is all going to come from the client table. That's client information. The property number is going to come from the viewing table. It's when a property is viewed by a client, a property number is viewed, right? Comment is also going to come from the viewing table. So what we do here is we say, okay, what columns do I want from what tables? Now, there will probably need to be in the where clause how the two tables are joined, okay? Because otherwise, if we don't have this, if we leave this out, right, then what we're going to do is we're going to get all all rows from the client table cross-producted with all of the rows from the viewing table. So if there were three rows in the client table, if there were 3 rows in the client table and 2 rows in the viewing table, we would get 6 results if we didn't include this where this in the where clause down here. Okay. What the where clause does is it says only give me the results where the client number from the client table results matches the client number from the viewing table results. So only where those two match do I want those rows to show up. Okay. This might be one of those things where here we go. Let's try to maybe show an example. Okay, so client Hoja. Okay, and then from the viewing table, now what our query would do initially in this, what it would do before the where clause is applied is it would say, okay, give me, I have no limit on the client rows. I'm just going to take all of the clients, right? And I'm going to, this is the result. Let's put the result down here. All of it here. Oh wait, I need a column name, sorry. And then I'm going to say, give me also all of these. Or sorry. But this one, give me all of these for this, right? Okay. Then it's going to do it again, but just this row. Okay. Now, what the where clause says is, okay, now I only want the results where client number in the client table matches client number in the viewing table. Okay, this one and this one, nope. So get rid of that one. So that one's gone. All right. This one and this one, yes, those match. So I want this. This one and this one, nope. So get rid of that. This one and this one, no. This one and this one, no. This one and this one, yes. Okay, so my result would be just these two rows. Okay, because the client number here matches the client number here. Okay, it's important to know that that's how that works with that cross-producting and stuff. Okay, all right. So a simple join like this is one of many ways that we could write this query, where we have all the tables listed, right, in the from, and then what columns to match on in the where clause. Okay, again, only rows from both tables that have identical values in the client number columns are included. Okay, we'll talk in a minute about why the C dot was used here, but it didn't show up anywhere else. We'll talk a little bit about that in just a moment. Okay. Basically, this is how that works. Okay. Now, there's a couple of other ways that we can also write the same SQL from the from clause on. We could say from client join the viewing table on this. All right. Okay. That's another way that it could be written. Okay. From client join viewing using client number. Now, one of the requirements for this second way, this, well, I guess technically third, but one of the requirements for this way of doing it here is that this client number column must be named the same in both tables. Okay. We could also write it using from client natural join viewing, meaning there is a natural join that is defined using a relationship between the two tables, the client and the viewing table. Okay. Personal experience. The first way I showed you guys, where I put all of the tables in the from clause and then put all of the how they're joined together as part of the where clause. That's how I learned to write SQL. That's how I use it. That's easiest to understand for me. It's not the easiest to understand for everyone, and so therefore that's why I can't say that it's the right way to do it. Some people, this makes most sense because it's saying, okay, I want a main table I'm choosing from, but I want to join another table on a particular criteria, all right, on a particular column joining. Okay, so this is perfectly acceptable. I would say these last two, I've seen those pretty infrequently. Could be that the databases I used that I worked on didn't have things in place to be able to make those a viable solution. I don't know, but this one that's up here and the one that's on the previous slide 2 slides ago are probably the ones that I'm most used to seeing. Okay. All right. We can do things like sort on different columns from different tables, right? So here we're sorting by branch number, staff number, and property number. So 2 columns from the staff table and then a column from the property table. right? Where we use both tables here, we join them, and then we order by the different columns. We can join more than just 2 tables. We can join 3 tables, right? I know, crazy. 3 whole tables? You crazy. But yes, we can. Natural join. Natural join would map them using the relationships that are defined if the using what's called referential integrity. So I think natural join does not require that the table column names be the same in both tables, but it would require that a relationship be defined. Okay. Again, I don't have a lot of experience with natural join, so don't quote me on that one. But yeah, and I can talk a little bit about column names and things like that. Okay, we can join 3 tables together. Branch B, staff S, property front P. Now notice that we have 2 connections in our where clause now. The branch number to the staff branch number and the staff number from staff to the staff number from property for rent. Okay. This is not, it's not always 1-to-1, or it's not always going to be like, oh, 3 tables, therefore there has to be 2 of these. It might be more, right? But basically, if you look at what we're doing here, let's see here. So we have a table here. We have a table here. We have a table here. Okay. The branch, the staff, and the property. Okay. Now remember what I showed you guys about how it did this whole cross product thing where it resulted in all of these extra rows that we kind of didn't think we wanted, right? And what happened, and the reason for that was we took all the rows from here and we mapped every row from here with every row from here. Well, that's happening in the 3 table join as well, right? Where in the 3 table join, it's saying, give me all the rows from the branch table with every row from the staff table, then take that and give me all of those results mapped to the property for rent table. So you see, I can get a lot of rows, right? But I only want the ones from the branch table that match the branch number with the branch number from the staff table. So what I'm saying is I want there to be a relationship here between the branch and the staff table. And then this staff and the property for rent table, there's a relationship there as well. In a sense, we're kind of making a graph out of these nodes, right? And what we want is we don't want there to be any abandoned nodes that aren't part of our result set. Right? In a sense, that's kind of what we're doing. In what is going to happen is that if we don't include one of these, what we'll end up with is we'll end up with a result from the other 2 for every single, like it'll be multiplied for every result in that table that's left alone. Okay. Again, just like before, we could also do this as in an alternative form. We say from branch B, join staff using branch number and join property for rent using staff number. Right. So there's alternative ways to write this as well. Okay. We can use multiple tables as part of a group by, order by, part of a aggregate function here. So we want to find the number of properties handled by each staff person. So first we get the staff branch number and the staff number based on the staff number being in the same in both tables. And then we count them using the group by. Just like before, like we said before, any column that's not part of the aggregate function must show up in the group by. Okay. It doesn't have to show up in the order by, it does have to show up in the group by. All right. All right. Now, all of the joins that we've talked about so far are what's called an inner join. Okay, meaning that it only gives us the result if it exists in both tables. Okay, so if the result, like for example, let's go back and show you this one. Notice that this first one here, Joseph, doesn't show up in my results at all, right? And the reason for that is that he doesn't, that number, client number, doesn't show up over here, right? And because that client number doesn't show up over here, it's not going to show up in the result at all. But what if I wanted to know that? What if I wanted to have, let's say, I wanted to have, I have a list of students, I have a table of students, and I have a table of courses, and I want to know all the students out of the university, even if some of those students aren't taking any courses, right? Well, student, course, right? Well, if this student isn't taking any courses, I don't see them, but I want to see them, all right? So the way we can do that is through what's called an outer join. Okay. Now, if we look at these two example tables, a branch number and a property for rent, okay, and I want to look at things based on what city they're in and what city the property is in, what city the branch is in, what city the property is in. Okay, if I were to do them using an inner join to say, give me everything from the branch, give me everything from the property for rent, where the cities are the same. Notice here I would get a result for that city that I don't know how to pronounce it, and I would get a row for the city of London. But Bristol there's a branch in Bristol, but no property, so it doesn't show up. There's a property in Aberdeen, but there's no branch in Aberdeen, so it doesn't show up. But what if I wanted to know that? What if I wanted to have all branches show up, but I also wanted to see which properties were in the cities that some of those branches were in? Right? Okay. So Bristol and Aberdeen don't show up. We can use an outer join. Right? So in this case, there's two types of outer, three. There's three types of outer joins, and we'll talk about them in order, left to right. Well, left to right to something else. So here we can say, give me the branch information, the property information from the branch table, left join property for rent on the city name. So what it means is it's saying, give me everything from the left, right? Give me everything from the left, and then on the right, give me things that match if they exist. Okay, and if there are no matches for a row on the left, then fill the right-hand side with nulls. So the left, we consider the left to be the branch table in this example because it's on the left of the query. All right. Property for rent is considered the right table. So it's going to give me everything from the branch, and it's going to give me the property for rent information based on the city name. And if there is no property for rent in that city, it just fills it with null. So it would look like this. So the branch information with the property in that city, branch information with the property in that city, and this Bristol one gets nothing because there is no property for rent in that city, but we still see it as part of the result. Okay? Kind of powerful thing that we can do here. Okay, here a right outer join. So we had left, we have right. Right just does the opposite. Right? Right says give me everything on the right. Or I guess right is you're right. Your right is this. So give me everything on the right. And then only the matching rows on the left. If there's no matching, fill it with nulls. something like this, where we would get all property information, right? And then fill with nulls those things where there's no matching. So Aberdeen gets the nulls. Okay. So we had left, we had right. There's one more. We had inner join, which is everything has to match. We had left outer join, which is give me everything from the left, and if it doesn't exist on the right, fill it with nulls. We have right outer join, give me everything from the right. If there's nothing on the left, fill it with nulls. Then there's a full outer join, which is basically saying I want everything on both sides, and anytime there's not a match on the other side, fill it with nulls. So here, Aberdeen, we still get to see it, but it gets nulls on the branch side. Bristol, we still get to see it, but it gets nulls on this side. Everything else matches. Glasgow, I think is how you pronounce it. No, that's not right. I know that's not right because I think that's how you should pronounce it, but my British friends say I'm wrong. But I can never remember what they say because I don't understand British English. And then London has a match. Okay. So we can use the exists and not exists. And I think this is the last of the select stuff before we start moving into data manipulation, right? We can use an exists and not exists keyword to see if a result exists in a subquery. Okay. Usually we can say to be the common subqueries for not exist or exists, for exists or not exists to be select star from the subquery to be select star. So that if any row shows up, it's easy to type instead of having to pick a specific column or something like that. All right, so we want to find all staff who work in a London branch. So our subquery is going to be give me the branches from B, right, where the city equals London. And this part right here is an interesting little notation that we get to add here, okay? Because notice that this S comes from the outer query, right? But we're using it in the inner query. That doesn't make a lot of sense, but it's really important, and we'll talk about why in just a moment. Okay, so but for now, what we're saying is I want, if there exists a branch with the city that equals London and the staff person works at that branch, then I want to get that result set. Okay. There are other ways to write this query, and I can give some examples of other ways to write this query. Maybe I'll do it. I don't want to do it in class today because I may run out of time. So what I might do is add it as part of the spreadsheet for today. Okay. So here, right? So we say, give me, if there's a branch that exists in the city of London that has the same branch number as my staff person, I want to see that in the result set. Okay. Now the reason why we don't just say select star from branch where city equals London is because that's true, right? This would always be true. There always exists a branch in the city of London. We have to specify that we're looking for a branch in London that has the branch number of the staff person we're looking for. Okay. Now, in this particular example, okay, it's an example to show how exists works, but it's actually probably a bad example of using exists, because this would be another way to write this query that would work just as fine. Okay. Oh, I was wrong. There's a couple more select things that we need to talk about. Forgot about the other stuff. All right. So here, where instead of using the exist keyword, we just join the two tables. And now, if a staff person works in a branch that's not London, they won't be part of this result. All right. branches that are not in London are filtered out, and therefore all staff who work at those branches are filtered out. Okay. Okay. So if anybody likes set theory, I kind of like set theory. Venn diagrams, stuff like that. I really like those things. But we can use those words in set theory like union, intersection, or intersect in this case, and difference or except to get different sets of results and put them together. Okay, and get a specified set of results. Okay, so let's take a look. Okay. So the union is everything from R and everything from S combined, okay? Not duplicated, so if there's something that exists in both R and S together overlapping, right? Then it won't give it to us twice. It'll just give it to us once because it exists in both of those sets. Okay. Intersection says, give me only those things that exist in both of the sets, okay, both results. Okay. And then difference says, give me everything in R that's not also in S. Everything in one set, but not also in the other. Okay. So if we look at it this way, right? So we can list all cities where there is either a branch office or a property. Okay. We can say select city from branch, where city is not null. Union, select city from property for rent, where city is not null. So we're saying, okay, give me all of the cities from the branch table, give me all of the cities from the property for rent table. Now show me the result that has where the city shows up in either of those two queries. Okay. Yeah, that was kind of weird. Right. So what we would do is we would get this, right? Okay. One thing, did it talk about this on the, let's see. The two tables, the two result sets must be union compatible. What that means is that the columns must be the same. So for example, you could have here, what we have here is a city, which is a text type column. City, also a text type column. They have to be the same. Okay. If we had multiple columns, they would all have to be the same data types in the same order. Okay. So we couldn't have like a text here and a numeric type here as part of a union. That doesn't make sense. Okay. We can't do that. Intersect says, give me only those things that are in both a city that's in branch and a city that's in property for rent. All right. I think that's wrong. I don't think Aberdeen was in both. Our slides are wrong. I don't think that's right. Okay. All right. So we could rewrite this query without the intersect operator. We could say, give me the cities. Oh, there's a missing comma. All right. Right. Give me the cities, the city from the branch, where city is the same as the city and property. Right. You should know why this would only give me the cities that exist in both. We could also say, give me the cities from the branch table, where there exists a property for rent in that same city. Okay. Multiple different ways that we could get the same information. Except want to list all cities where there's a branch office but no properties. So we're going to give me all the cities from the branch table except those cities that exist in the property for rent table. Okay. And just like with the intersect, we could also rewrite the query without the except keyword, right? Where we could say, give me all the cities from the branch, give me the distinct cities from the branch table, where the city is not in the city from the property for rent table. okay, or where not exists a city in the property for rent table. Okay. You got a question or comment? Okay. All right, so that ends our select discussion. Are there any questions or comments? Like I said, I will probably be putting some examples in that spreadsheet of different ways that we can write some of these things. Are there any questions, comments about select before we move into data manipulation? How to change data? Because all this discussion so far has been, how do we see the data? How do we get the data from the database? All right, let's talk about how to first put data into the database. All right, so the way that we're going to add data to a table is we're going to insert data into the table. So insert into table name, optional column list. If we leave the column list out, it uses the default the column order that is in the create table, the way that the table was created. Okay, so we don't have to include the column list. It can be helpful in some situations, and we'll talk about that. Okay. Any columns must have been declared as null when the table was created, meaning that it could take a null value, or a default must have been specified, right? And the data value list must match the column list. Okay, and it's think of it as you're calling a method, right? And the parameter list that when you call the method must match the argument list, all right, of the method signature. Right, same thing. So think of this as being the what is it? The parameter list, right? And think of this as the parameters that you are passing to that method. Right? Okay. Column list again is optional. If it's submitted, it assumes a list of all columns in their original order. Right. There's a couple of different ways that we can insert data into the table. One is by using the values keyword. So here we're going to insert into staff values. Notice the column list is missing. There is no column list. And the reason we did this way is so that we don't have to type it all out if we're going to insert a value for every column. So we give our staff person a staff number, a name, a last name, a position, a sex, a birth date, a salary, and a branch number. Once this query is run, this row will be inserted into our table. Okay. We can also insert using defaults. So here we can say insert into our staff table, but we're only going to insert these particular columns, and we're going to be null for the others. What was it? Sex and birthday, date of birth, right? So here we just list out the columns we want to put values into, and we don't put values for the other columns. Or in this example, does the exact same thing for those columns that we don't want to put values for, we just say null. Okay. So this is how you can insert single rows at a time. Okay. But this is not where the power of insert into really lies. Okay. The power of insert into is when we can insert multiple rows at a time. Okay. We can insert into a table, again using the column list, using the result of a select. So we select, making sure that our select column list here matches whatever the column list is here. Right? And whatever the select query gives us, those results will be inserted as new rows into our table. So let's say that there was a staff prop count column. That what we maintain, what we keep in this table is the staff, their name, their last name, and how many properties they are managing. Not which properties they're managing, but just how many properties they're managing. Okay. We can populate the staff prop count table using the staff and the property for rent tables. This. Okay. So now remember, the column list is staff number, first name, last name, property count. So here, there's two parts to this. One, we're going to select the staff number, the first name, the last name from the staff table, and then a count of how many times their number, their staff number, shows up in the property for rent table using our group by. Okay. So this tells me staff number, their name, their last name, and how many properties they are managing. Now, why do we union this other query? What does this other query represent? Why do I have this second query after the union? Anyone? Is my microphone working? Good. Thank you. So why do we have this second one? We just don't know. Okay. Yeah. Well, notice the value that I'm inserting here, right? So here I inserted the staff number, the name, the last name, and how many properties they were managing. Here I'm inserting the staff number, the name, the last name, and a 0. You remember when we talked about just like what, 10 minutes ago, 20 minutes ago maybe, how we talked about how if this is what's called an inner join. So if a staff person isn't managing any properties, their information won't show up in this result. So this is saying, okay, I also want to get those staff people who don't show up in the property for rent table at all. I want to get those staff people who aren't managing any properties. But for the number of properties they're managing, I want that to be 0, because if they're not in the property for rent table, they are not managing any properties. All right. So I still want them to show up because they are part of our staff. They just aren't managing properties, which doesn't mean they're not working. Okay. There's people that work for the university that don't teach classes, right? And they work really hard. The rector, for example, I don't think she teaches any classes, all right? But she works hard. All right. So when that union happens, when this select happens, any rows that come from this are going to be inserted all at once into the staff prop count table. Is it 1 row? Is it 2 rows? Is it 1,000,000 rows? It could be any of those things. And it happens all at once rather than having to insert them one at a time. Okay. And this is kind of where a real powerful aspect of insert into works. Okay. So again, so this could be like the result that we end up with. Okay. So that's how you add data to a table. Okay. We might want to update data in a table, change it, right? We want to change the values for a column or columns. Okay. The way we do that is by using the update keyword. So we update our table we set a column to a certain value with an optional where condition. Okay, if we don't specify where, all rows are updated for that column. Okay, so if we said update salary equals 1 million, right, and we didn't put a where clause, everybody in the company would have a new salary, right? If we use the where clause, then only the rows that satisfy, only the rows that would be affected are updated. Okay, so some examples here. We might say, give all staff a 3% pay increase. So update staff, set the salary equals salary times 1.03. So every row in the table, in the staff table, their salary is now set to whatever it was times 1.03. So a 3% increase. Here, give managers a 5% pay increase. Right? So where the position is manager, we're going to change the salary value only for the manager rows. Okay. We can also update more than one column at once. We can say update the staff table, set the position to manager and the salary to 18,000 for a particular staff number. Okay, so any row in the table that the staff number is this value, SG14, the position will be manager, the salary will be 18,000. Okay. So that's how you update. That's the basics of how you update a row. Okay. Delete is how we remove data from remove a row from a table. Okay. Just like with all of our other queries, the search condition is optional. If we don't have the where clause as part of a delete, we delete all the rows from a table. Now, I want to make sure you guys understand this. This does not remove the table itself. It only removes the rows from the table. Removing the table itself is something else. We'll talk about that tomorrow when we get into the advanced SQL. Okay, but for now, know that deleting from table deletes the row, only the data. If we delete all the rows, the table itself is still there. There's just no rows in it. It's kind of like a folder without any files in it. Okay, it's still there. It just doesn't have anything in it. Okay, so if we delete from viewing where property number is PG4, we're going to delete all viewings for that property. Delete from viewing with no where clause gets rid of all the records from the viewing table. Okay, let me do one thing. Let me caution you guys about delete, by the way. Oftentimes we think, oh, delete, that's how we get rid of information from databases. And so whenever I remove a post from Instagram or Facebook or Twitter or WhatsApp or whatever, if I remove it, then they deleted it from the table. That's not usually how that works out there in companies. Is a lot of times is to remove a post, it just gets hidden. It's like a little flag in a column on the table gets where it's hidden, where no one can see it anymore, but the data is still there. Okay, so just let me use this as an opportunity to caution you that, as I've cautioned a lot of my students and my children and my friends, is anytime you put something out on the internet, it's pretty much there. You can't ever get it where it's never there anymore. Okay, it's always going to be out there somewhere. Okay, in fact, even old versions of websites are still out there. If you go back, if you go look up, there's a thing called Wayback Machine. It's a website that caches old versions of websites. It's pretty interesting to go look at some of your favorite websites in the Wayback Machine and see what they used to look like. Okay, all right, so that was my caution, my fatherly caution for the day. All right, let's see. All right, so that's the end of our slides here. Yep, that's it. And are there any questions before we end for the day? So right at 3:20. All right, so right at 3:21, we were able to finish right on time. Are there any questions before I dismiss you? Okay, guys. Well, have a good evening. We will come back tomorrow morning and we will start talking about, it's called Advanced SQL. Probably more accurate to just call it Data Definition SQL, that it's the ways that we create and manipulate the structures of the database like tables and views. Okay. All right. Have a good afternoon. I'll see you tomorrow morning.